Hi everyone, and welcome to our video where we will be solving a trig equation by squaring both sides. Now, we've been doing a lot of trig equations where we've had multiple, so I've left all this work up from previous videos, and it involved a lot of factoring, and we wanted one side to be 0, and then we looked to factor for majority of these more complicated trig expressions or trig equations. Okay, so that's how we broke it down, or we even used identities eventually if we had special scenarios like these previous two. Well, in this, we have a mixture of trig functions. This is a case where we wouldn't want one side to be 0 because if I change, so I'm gonna just scribble this out. Well, let's put it way to the side. So if I subtracted the radical 3 cosine of theta over, there's nothing I can do. So we usually want one side to be 0 so that we can factor or use an identity. But these are the lowest powered trig functions and the most basic trig functions, sine of theta and cosine of theta. So that means there's not really anything we can do. So like maybe if there's a tangent or cosecant or whatever, we could at least apply reciprocals to see if it simplifies in a different way. But here there's nothing we can do with this. So that's why this is a special case. Here when we have a mixture of trig functions, but no higher powers, we would need to square both sides. Okay, so that's what we're doing on this. So this part didn't help. So what we'll do instead, I'm just going to write it right below. Again, just to show, oh, we do need to square both sides. The reason for that is because, yeah, currently I don't have anything I can do. But if I square both sides, I would have trig functions that are squared, which means I can use a Pythagorean identity. All right, now the left has a plus sign in it when it gets squared. So that means we should rewrite it out. So the same thing times itself so that we can FOIL it correctly. Even this one, I mean, we can. Anytime you have a square, you can always expand to see it the long way, like that. All right, and so let's multiply these things out. So this left side FOILs. So sine of theta times sine of theta is sine squared of theta. And then sine of theta times 1 is sine of theta. 1 times sine of theta is also sine of theta. 1 times 1 is 1. And then equals square root of 3 and square root of 3 is 3. Cosine of theta and cosine of theta is cosine squared theta. Okay, so we multiplied those things out. And then let's do 2 steps in 1. Now that I've got squared expressions, I am going to go ahead and combine that. So I have sine squared of theta plus 2 sine of theta plus 1. And then let's subtract the 3 cosine squared over. So minus 3 cosine squared theta set equal to 0. All right, so I've got these trig expressions that have higher powers. Still currently I can't factor anything. But looking at this, I've got a sine squared and a sine. So that means this cosine squared of theta should change to match the sines. Well, that's where we would use a Pythagorean identity again. Remember, our original is sine squared of theta plus cosine squared of theta equals 1. If we subtract sine squared over, we would have cosine squared of theta is 1 minus sine squared of theta. Okay, so that in the blue parentheses will change. So we have sine squared of theta plus 2 sine of theta plus 1 minus 3 parentheses 1 minus sine squared theta. All right, so we used an identity so that our expression is in terms of only sine. Now that it's in terms of sine, well, let's distribute the negative 3 and then combine like terms. So we would have sine squared theta plus 2 sine of theta plus 1. And then distributing the negative 3 gives us minus 3 plus 3 sine squared theta. Okay, so combining the like terms, I've got a sine squared of theta plus 3 sine squared of theta. So that's 4 sine squared of theta. And then I also do have, well, let's get the plus 2 sine theta just written. And then I also do have plus 1 minus 3. That would be minus 2 equals 0. Okay, so now we've got this expression where we see, oh, it's a quadratic, or it's in quadratic form, because I have a squared trig function and a non-squared, and they are the same sign of theta at least, except just one's squared and one's not. So that means it should factor nicely. Well, first step in the factoring, notice 2's in common in all terms. So we should factor the 2 out. So I have 2, and then 2 sine squared theta plus sine of theta minus 1. Again, we could distribute the 2 to double check. It does match directly above. And then we want to keep going with it. Okay, so this 2 is just out. And then I have a quadratic. All right, so with a quadratic, I know it factors into 2 binomials or expressions with 2 terms. And then I want to use my first term here to say, well, how do I get something times something to be 2 sine squared theta? Well, the only option is to do 2 sine of theta and sine of theta. So that multiplies to give me 2 sine squared of theta. And then I see a minus 1. All right, so this minus 1. The only way to get 1 when multiplying is 1 and 1. And then I just need to make sure my signs are good. I think I need to do a minus here and a plus here. And when we FOIL it, it does check out. 2 sine of theta times sine of theta is 2 sine squared of theta. 2 sine of theta times positive 1 minus a 1 sine of theta is still positive sine of theta. Negative 1 and positive 1 is negative 1. All right, so it's a match. Now that we've got it factored, you can set each factor to 0. Well, this 2 getting set equal to 0 is nonsense. 2 equals 0 is false. So that means you can move on. There's no variable to solve for. Okay, so that doesn't mean anything to us. Here, when we set things equal to 0, we can find the variable that we're trying to get. Okay, so I have 2 sine of theta minus 1 is 0, and I have sine of theta plus 1 is 0. Well, the first equation, I can add 1. So I have 2 sine of theta equals 1, and then divide by 2. So I have sine of theta equals 1/2. And then the second equation, I could subtract the 1 over. So I have sine of theta equals negative 1. All right, well now, let me go ahead, we'll put our unit circle over here. Give ourselves a little bit more room. And then I'm going to color code it. Okay, so where I have sine of theta equaling 1/2, so again, that's a y-coordinate. Sine of theta equaling 1/2 means my y-coordinate of 1/2 is at pi sixth and at 5 pi sixth. And then where sine of theta equals negative 1 would be down here. Okay, so the y-coordinate of negative 1's at 3 pi over 2. Okay, so there's our 3 answers between 0 and 2 pi, or at least they look like answers. Now we have to go back one more thing. All right, so it looks like, so if this was any other problem, we often would say, well, we have it. We would say pi 6 plus 2 pi k, 5 pi 6 plus 2 pi k, and 3 pi halves plus 2 pi k. And then we'd box that up and say we're done. Well, unfortunately, this problem, we can't do that. So if we square an equation, we have to check our answers. All right, so in previous problems, we did check some of them as we were going through these videos. So if you didn't view the videos here with all this work, I mean, it's worth double checking them and going back and making sure you feel good about it. But we often save some time by not fully checking the answers, and I just stated, oh yeah, they'll work. Double check for me. Okay, so but they will. Okay, so these ones did. However, none of these involved us squaring. Okay, so we squared something in this problem. On these problems, they had squares in them, but we didn't do the squaring. We did not put it into the equation, so it was already part of it. Okay, so on this, we squared. We put that in. Well, squaring is irreversible in math, and what I mean by that is, like, if you had x equals 1, so this is already solved for, But if I said, oh, let me square both sides, so I would have x squared equals 1, and then let me square root. Square rooting gives us plus minus. So what I just did is I had an answer already, or an equation where it was already solved for and I shouldn't be doing anything to it. And then I put in a square on both sides. Let me put it even like that. And then I square rooted to get back to a final answer. Well, this answer is saying I have 1 and -1. But when I plug -1 into the original, okay, so that's an X to say it's bad, it doesn't work. Okay, so that should not have been an answer. So squaring still gave me the original answer, but it gave me an extra answer as well. We call that extraneous, and we don't want it. All right, well, the trig functions do the same thing, where maybe some of these are no good. So that means I have to check. All right, well, it's not that big of a deal to check. Let's get it going. We always check our original equation. So sine of theta plus 1 equaling square root of 3 cosine of theta. So it's always back to the start. And then we'll check theta equals pi 6 first. Okay, so, and I'm gonna, let's show it in this one. So sine of pi 6 plus 1 equals radical 3 cosine of pi 6. Well, sine of pi 6 is 1/2 plus 1, and then radical 3 cosine of pi 6 is radical 3 over 2. This is going to be true. So the left is 3/2, the right is 3/2. So 3/2 does equal 3/2. Good. Okay, so that means this is an answer so far. I'm just going to put a check mark. Good. The 5 pi 6th one. So if we let theta equal 5 pi 6th, okay, so I'm going to do that work right away because I'm running low on space. But sine of 5 pi 6th is 1/2. Cosine of 5 pi 6th is negative radical 3/2. This is not going to work. So this is positive 3/2. We can squeeze that in, I guess. 3/2. This is negative 3/2. So it's saying 3/2 equals negative 3/2. That's not true. So that means this one should go away. Goodbye. Okay, and then we will also want to check the final 3 pi halves answer. Okay, so it's again running low. Let me do it in green. I thought I would have had enough room. Sorry, I'm going to put that underneath. So when we check 3 pi halves, and going into this theta, sine of 3 pi halves is -1, and then plus 1 equals radical 3. Cosine of 3 pi halves is 0. -1 plus 1 equals 0. Radical 3 times 0 is also 0. So that means that one is good. Okay, so we have those two answers with the plus 2 pi k's to them for a final answer. And so I'm just going to double cross that out. So instead of rewriting, since I'm out of room anyway, we only have those two answers. Okay, so that's the kind of the worst case scenario for our trig equations, and it doesn't look like the worst case scenario. It's looking more basic than some of the other ones we saw, but it is the worst. Okay, so you can see why. All right, well, but that is it though. All right, so if you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.